In this video I will do a recap about limits, okay, and I will do more or less every kind of limit, let's say. So basically I'm gonna pick a random past final, and I will do all the questions on limits from that final. Before I start, I just want to make sure that you understand that this is not as mathematical, okay, as it should be. This video is about giving you some kind of strategy how to approach this question on the test and on the final, okay? So all of you who are going to continue studying mathematics at university, okay, do not rely on this video as much. You basically have to learn the theoretical side of about the limits. This is just preparing you how to do the questions on the test and on the final, okay? So basically, first of all, we can divide all the questions about limits that you're going to see in two big groups of limits, okay? One of them, a limit of a function, okay, the first big group, as x approaches a particular constant, okay? And then the second one being the limit of a function where x goes to positive or negative infinity. Basically, the second limit here talks about the behavior of the function at towards negative infinity and towards positive infinity. In this first type of limit here, there are a few scenarios that can happen. First of all, before I continue with the scenarios, whatever the function is here, the first step that you want to do when x approaches to a constant here is direct substitution, okay? Which will not work for this limit right here, okay? We cannot use direct substitution. Why? Because infinity is not a constant. You cannot just plug infinity and hope that it will give you some kind of answer, okay? So after the direct substitution, a few scenarios can happen. Of course, I'm limiting these scenarios to what you might expect on the test rather than what to expect in real life, okay? The first scenario is where you get a, as x approaches to a, the numerator and the denominator are approaching to constants m and n, where m and n are different than 0. And if this happens, you're done, okay? Because this is your answer, okay? The second scenario is where the numerator approaches to a constant different than 0, but the denominator approaches to 0, okay? So the numerator is different than 0. And in this case, a limit of p of x over q of x will approach either positive or negative infinity as x approaches to a. And now, if the numerator stays away from 0, but the denominator approaches to 0, right away, the result, the answer is going to be positive or negative infinity. The difficulty about this question is determining what's the sign of infinity, positive or negative. The third type of this limit is when the numerator and the denominator are approaching to 0, okay? And if both the numerator and the denominator are approaching to 0, then we have few types of strategies how to simplify that so that we're going to end up with either the first one or the second one after the simplification. So if you have 0 over 0 limit, then you have to do some kind of manipulation with this expression, which will lead you to one of these two cases. As you can see, these two cases give you an answer. 0 over 0, you don't know how much it is, so you have to continue working on it, okay? And usually what we do, sorry about the light. Usually what we do is, one of the strategies is factoring. And I've told you, if x approaches to a and you get 0 over 0, there is a factor of x minus a that waits to be cancelled. Or rationalizing first and then factoring and then cancelling this factor. Or simplifying if the expression is a complex fraction, first simplifying, dealing with complex fractions, then factoring this factor, cancelling it, and which will lead you to either this case or this case. Okay. One of the 0 over 0 limits is sine of theta over theta, right? And as I said, this is as theta goes to 0, I have 0 over 0, but this is a known limit that is equal to 1. It's a staple question. Okay. And among these, you should expect that somewhere here, one of these expressions or part of this expression is going to be put in absolute value. Okay. What other questions you might get? You might get, when x approaches to a, you also might get infinity over infinity, okay? And after simplification, that will lead you to 0 over 0. So a fourth big group of this, it might be infinity minus infinity. Or as a matter of fact, infinity over infinity. Usually this is type of question where complex fractions are involved, okay? And then you simplify that, you end up with 0 over 0 limit, and then usually is one of these or a combination of these approaches in order to deal with 0 over 0, which will lead you to a constant different than 0 divided by constant different than 0, right? If you can cancel this factor on top in the numerator and in the denominator, or a constant different than 0 over the denominator that approaches to 0, in which case, again, you know that the answer is infinity. All you have to do is decide whether it's positive or negative infinity. Okay? When x goes to positive or negative infinity, then the situation is slightly different, okay? Usually we have infinity over infinity, so you might get infinity over infinity. How do we deal with this? Well, you factor the highest exponent, right? In the numerator and in the denominator, because that one leads to infinity. Cancel those and check what is going to happen after that. Or, as I said, you can have infinity minus infinity, in which case first you simplify, okay, and try to bring this expression in this form, right? Simplify or factor, again, the highest exponent, which either will give you the answer or it will simplify to this type of limit, in which case you factor the highest exponent and then continue, okay? So basically what I'm trying to say here is that when you're going to do this question on the final, and as you can see in the past finals, this is usually one of the first 2-3 questions, the first idea is check whether it goes to a constant or it goes to infinity. If it goes to a constant, first of all, use direct substitution. If the direct substitution leads you to a constant different than 0 divided by 0, the answer is either positive or negative infinity. And as I said, the difficulty lies here, determining what the sign is. Or you get 0 over 0, okay, most of the time, in which case you use one of these methods, okay? in order to simplify the expression, and that will lead you back to either this case or this case. And somewhere in between, depending on how the question is phrased, lies the squeeze theorem. And the squeeze theorem can be used for this type of limits or this type of limits, depending on the question. Okay, so let's do a few examples here for all the questions. For all the examples, the question is solve the following limits, and you will see how this question will fit in one of these situations. Okay, so let's first evaluate the limit as x approaches to 3 of 3 over 7 minus x over 3x minus 2 over x minus 3. Okay, you can do this on the side, or you can do it right here if you want. First, you use direct substitution, and then you see that 3 over 7 minus 3 over 3 times 3 minus 2, right? You just substitute 3 for x. So 3 times 3 is 9 minus 2 is 7. The numerator goes to 0, right? So the numerator approaches to 0. The denominator approaching to 0 is evident, right? Over x minus 3. So you get 0 over 0. Okay. So as you can see, first I have to, because there is, okay, before I can show you, what did I say in class? If x is equal to 3 gives you 0 or 0, that means that on top and on bottom there waits a factor of x minus 3 to be cancelled. Okay, that factor is obvious in the denominator. Now we have to simplify, so you get 0 over 0. Right away factoring is not the option here. First we are dealing with complex fractions, so first simplify, then cancel. So how are we going to simplify this? First, bring the numerator under common denominator. The common denominator, these expressions are relatively prime, so it's 7 3x minus 2 times 3, on top of I have 3 times 3x minus 2 minus 7 times x over x minus 3. Now this is equal to the limit as x goes to 3 of 7 times 3x minus 2 times x minus 3, and drop the parentheses here, you get 9x minus 6 minus 7x. Now 9x minus 7x is 2x minus 6, as x approaches to 3. In the denominator I have 7, 3x minus 2, x minus 3. And now, one more time, I'm reminding you, because here we haven't done any canceling so far. So still, if you apply direct substitution here, you should get 0 over 0. If you don't get that, that means somewhere you made a mistake. And that's obvious. 6 minus 6 is 0, right? So the factor x minus 3 that waits to be cancelled here is obvious. How I'm going to obtain that one in the numerator? Just by factoring 2. Once we have cancelled the problematic factor, okay, now we try direct substitution one more time. And then you see we had a 0 over 0 limit. We cancelled that factor that was causing the problem, that was giving us 0 over 0, and then inevitably you end up either here or here. Okay, if you get 0 over 0, you repeat the procedure until you get either constant divided by another constant, both of them different than 0, or a constant different than 0 divided by 0. So you use direct substitution one more time, and you get 2 over 7 times 3 minus 2, which is 2 over 7 times 7 is 49. For the rest of the video, I would suggest you for the rest of this video, I would suggest you, whenever I start a problem, okay, for you to pause this video, okay, try to solve it by yourself, then look at the video, compare how you solved it compared with the way I solved it, and then check whether you got the right answer. The next question is x approaches to -3 from the right of x squared plus 6x plus 9. Okay, on the side you can evaluate this direct substitution. -3 squared is 9 minus 9, which goes to 0, which is 0, right? So that means that the numerator goes to 0. And then the denominator is -3 squared, which is 9, plus 6 times -3 plus 9. 9 plus 9 is 18. 6 times -3 is -18, so 18 minus 18 is 0. So indeed I get 0 over 0 limit. It's the same thing again. Now I'm trying to cancel, because I get 0 over 0. X minus this constant is a factor here and here. That means that I want to cancel x minus -3, which means I want to cancel x plus 3. Okay, that's the factor that's causing the problem. Well, even without that, you should know how to factor difference of squares. That's x plus 3 times x minus 3. For this quadratic expression, knowing one factor of it, x plus 3, makes the factoring much easier, right? With what do I have to multiply x to get x squared? That's x. With what do I have to multiply 3 to get 9 plus 3? And obviously, that factor that gave us 0 over 0, now here waits to be cancelled. So I'm going to rewrite this whole, the line that's left, just that our next step is going to be a little bit more clear. Now again, I have cancelled the factor. Try direct substitution. See where it's going to lead you. The numerator goes to -6, the denominator goes to 0. Okay? So as you can see, we started with 0 over 0 situation. We factored the problematic factor and cancelled it. And it led us to this kind of situation, a constant different than 0 divided by 0. And in that case, the answer is infinity. Now you have to check whether it's positive or negative infinity. Okay? So right away you can write here that this answer is infinity. Now we have to decide what's the sign of it, right? So the numerator obviously is negative. What about the denominator? Well, I'm approaching -3 from the right. So if you approach -3 from the right, all of these numbers, right, are greater than -3. So you can test it if you want, but any number greater than -3, right, plus 3 is going to give you a positive number close to 0, but positive, right? So this approaches to 0 from the right. And then the numerator is negative, the denominator is positive. Negative divided by positive gives you negative infinity. Problem 3. Limit as x goes to 0 of x plus sine of x over tangent of x. Again, try direct substitution. 0 plus sine of 0 over tangent of 0 is equal to sine of 0 is 0, so 0 plus 0 is 0, tangent of 0 is 0. So here, obviously you have to use, right, this type of limit, okay? That's at hand. So one way to approach this is simply to, this is limit of a sum, and limit of a sum can be written as sum of the limits. So this is equal, so limit of the sum, right, is equal to the sum of the limits Now I'm going to express tangent of x as sine of x over cosine of x. You guys know that already. Okay, and then I'm going to deal with this division of this fraction of fraction, division of fraction. So this is limit of x times cosine of x over sine of x as x goes to 0 plus limit of sine of x times cosine of x over sine of x as x goes to 0. Okay? So what do we know? We know that sine of theta over theta as theta goes to 0 approaches to 1, but also theta over sine of theta as theta goes to 0, this ratio approaches to 1. So x over sine of x as x goes to 0, this ratio approaches to 1, which leaves us with limit as x goes to 0 of cosine of x plus, here is the same factor, so we cancel it, sine of x over sine of x, limit as x goes to 0 of cosine of x. And then use direct substitution, you get cosine of 0 plus cosine of 0, that's 1 plus 1, which is equal to 2. Pay attention that here I cancel the same factor, here I don't cancel x and sine of x, you cannot cancel x and sine of x, but the limit as x goes to 0 of x over sine of x approaches to 1. The next problem, problem 4, is the limit as x goes to 0 of 2 times cosine squared of x minus 7 cosine of x plus 5 over cosine of x minus 1. So if you use direct substitution, you get 2 times cosine squared of 0 minus 7 times cosine of 0 plus 5 over cosine of 0 minus 1. Now cosine of 0 is 1, so that's 1 squared is 1. Cosine of 0 is 1 times 7 is 7 plus 5 over 1 minus 1 is equal to 0. So cosine of 0 is 1. That means that I have to cancel a factor of cosine of x minus 1. Right? This whole factor here waits for us to be cancelled. Cosine of x minus 1, because when I plug here 0, cosine of 0 is 1, 1 minus 1 is 0. So now I want to cancel cosine of x minus 1. Okay? That factor here waits for us. The question is, how are we going to deal with the numerator? One way to do it is, if you're aware of what you want to cancel, then you treat just cosine of x as another variable. How would you factor 2u squared minus 7u plus 5? If u was 1, well, that's going to be u minus 1 times 2u minus 5. But I don't have u, I have cosine of x, so sorry about that. 2 times. So limit as x goes to 0, cosine of x minus 1. With what do I want to multiply cosine of x to get 2 times cosine squared of x? Well, that's 2 cosine of x. With what do I have to multiply negative 1 to get positive 5? That's negative 5 over cosine of x minus 1. If this is too much for you, then literally on the side, substitute. Let cosine of x is equal to u, and then you have 2u squared minus 7u plus 5. If u is equal to 1, for u is equal to 1, this expression is 0. That means one factor is u minus 1. With what do we want to multiply u to get 2u squared? That's 2u. With what do we want to multiply negative 1 to get positive 5? That's negative 5. And now write it back in terms of, because cosine of x is u, we used u as a dummy variable here, just to simplify this expression here. And then you get cosine of x minus 1 times 2 cosine of x minus 5. And now you have the factor to be cancelled. Use direct substitution. 2 times cosine of 0 minus 5 is 2 minus 5, which is equal to negative 3. Okay. The next question, x approaches to negative infinity. X squared minus 1 minus 7 minus 2x over x minus 2. Okay, so this is the first time where out of this selection of problem an x doesn't approach to a constant like here, but actually approach to either positive or negative infinity. Now direct substitution, as we think of here, it's not going to be applicable. Okay, you have to use some different kind of thinking about this problem. If x goes to negative infinity, if you go towards negative infinity and you subtract 2 units, this still is going to go to negative infinity. What about the numerator? Well, this is going to go to positive infinity. This is going to go to negative infinity. With negative in front, you get positive infinity. Infinity plus infinity, this expression goes to positive infinity. So I have infinity over infinity situation. Okay? So how to deal with this? Okay? Let's just factor out the highest exponent. So this is equal to the limit as x goes to negative infinity. The highest exponent in the denominator is just x. So I have 1 minus 2 over x. In the numerator, you have to work a little bit you have to work with the square root a little bit in order to factor out the highest exponent. So the highest exponent in the numerator is x, although here it's disguised a little bit. So first I factor x squared under the root, which leaves me with 1 minus 1 over x squared. Minus, for this factor out x, and you're left with 7 minus 2 over x. Okay. Now, as we said in class, sorry, this is negative infinity. Square root of x squared is absolute value of x, square root of 1 minus 1 over x squared, minus x, 7 minus 2 over x, over x, 1 minus 2 over x. Now here, just a reminder, absolute value of x is negative x if x is less than 0, and positive x if x is greater or equal to 0. Now as we go towards negative infinity, right, all of these numbers are going to be negative, so absolute value of x becomes negative x, and that's how we get rid of the absolute value. So limit as x approaches to negative infinity. Absolute value of x, we just said, is going to become negative x based on what? Based on the fact that x goes to negative infinity. So all of these x's are negative. When we drop the absolute value, it's going to become negative x. So this becomes negative x square root of 1 minus 1 over x squared minus x 7 minus 2 over x. over x 1 minus 2 over x. And finally, I can factor out x here and here, right? I made a mistake. Sorry, guys. When I factor x from this factor, I'm left with 7 over x minus 2. Sorry about that. So I factor x, I am left with 7 over x minus 2. That's 7 over x minus 2. That was a very, very bad mistake on my part. So here I can factor negative x, and I'm left with this root here, square root of 1 minus 1 over x squared, plus 7 over 2 minus 2. Okay, over x 1 minus 2 over x. Now cancel these two, send x to infinity, right? We know that if the numerator is any constant and the denominator goes to positive or negative infinity, that ratio will approach to 0. This is 7 over x. I don't know why I'll keep on making this mistake here. The numerator is 7, the denominator goes to negative infinity, that ratio will approach to 0. Similarly with this ratio, leaving us with negative square root of 1 minus 2 over 1. Well, that's negative 1 minus 2 over 1. This is negative 1, right? So negative 1 is equal to 1. And the last question. Limit as x goes to infinity of 2x plus sine of x over 3x as x goes to infinity. Okay? As x goes to infinity, the numerator goes to infinity and the denominator goes to infinity. For the denominator, that's obvious. The numerator, it's 2 times something that goes to infinity, that's going to be infinitely big. And then plus sine of x. Well, sine of x at most can be 1. So 1 added to something that goes towards positive infinity, stays positive infinity. Or sine of x can be at least negative 1. Sorry, the minimum value of sine of x can be negative 1. So if you subtract 1 from infinity, still is going to go towards infinity, right? So I have infinity over infinity. You can solve this problem in few ways. Right? One way, straightforward, would be to split this just to split this expression. Here you cancel x and x. Okay, this will go to 2 over 3. And then how are you going to deal with sine of x over 3? So here you have to use the squeeze theorem. Okay, so sine of x is bounded between negative 1 and 1. Now as x goes to infinity, right, that means that all the x's are going to be positive numbers. So if I divide by any positive numbers, this inequality is not going to change. So negative 1 over x less or equal to sine of x over x less or equal to 1 over x. As a matter of fact, if I divide it by 1 over 3x, also nothing will change. Okay? And now I have my expression right here, bounded by 1 over negative 1 over 3x and 1 over 3x. But now send x towards infinity. This here, negative 1 divided by something that goes to infinity, will be 0. and 1 over 3x as x goes to infinity, that means the numerator stays at 1, the denominator becomes infinitely big, their ratio is going to go to 0. So from here, by the squeeze theorem, sine of x over 3x will approach to 0 as x goes to infinity. So obviously sine of x over 3x will go to 0, and this limit is just 2 over 3. That's the answer. Another way you can solve this limit is because I get infinity over infinity, right? Factor out the highest exponent in the numerator and the denominator. In this case, that's going to be x. So sine of x over 3x in the denominator is already factored. First cancel the common factor, and now send x to infinity. Now again, don't be confused by sine of theta over theta as theta goes to 0. Here theta doesn't go to 0, it goes to infinity. So this ratio goes to 0 by the squeeze theorem, right? Here in this expression was sine of x over 3x. You can repeat the same logic in order to get that sine of x over x will approach to 0. And again, 2 plus 0 is 2 over 3 times 1 is 3. So you get the right answer. And now I would suggest you to follow this. Scheme, okay, when you prepare these questions for the test. It's just a recommendation. You don't have to, okay, but do as many problems as possible from the past finals for the upcoming test.